let whatever it is, we'll just leave it. Anything's better than nothing. Alright, so we ready for this? Still in section 2.6. Domain. That's what it's doing left to right, based on the x-axis. Remember, the only thing on this whole list that's based on the y values is that range. Everything else is based on the x's, right? Domain, all the way, it's pointing all the way to the left, so it's going from negative infinity, but what happens right here at negative 2? It's got a hole in it, so we got to cut it off there. So it's going to go from negative infinity to negative 2. We'll use a parenthesis because that point's not included. Then it picks back up here at negative 2, and it goes everywhere else. Everything else. That's the yeah, 1, 2. Okay? But then you notice here from this negative 2, everywhere else is solid, right? So we'll say union from negative 2 on to infinity. So the only place where this graph has a hole in it is when x is negative 2. Every other x value is defined. It's a part of this function. You good there? Now let's look at the range. The range is what it's doing y values, bottom to top. Well, what's my lowest y value right here? 2. So my range, and 2, do you agree? Y equal 2 is included. You have, this was open, but it's closed everywhere else. So it's going to be a bracket on that 2, and then they're both going up. So it's from 2 to infinity is your range. Now we're going to do increasing, decreasing, constant. So let's trace it from left to right. What does my pen do?
Decreasing.
Decreasing, so that means I'm decreasing here from negative infinity to negative 2. I use a parenthesis because that's not included. Okay, what am I doing here from negative 2 over here to positive 1?
Constant.
Your constant. You see that one, what constant looks like over here? That flat line, that's constant. Good deal. So from negative 2, which has a parenthesis, from negative 2, which has a parenthesis, over here to 1, and 1 will have a bracket because 1 is included. Right? 1's a solid dot. It's included in my graph. Now what is it doing here from 1 on to infinity? Increasing. Now 1 was included, so I'll put a bracket on that 1, and it goes to infinity. Would you say this graph is continuous, yes or no? No, it's got a hole in it. No. But it is continuous over its domain. And so if you're doing it in your homework, on your My Math lab, it'll say, write it like on your book. Where did it say that? Pages flip back. In your book, in 2.6, your directions read, determine the intervals of the domain over which it's continuous. So basically it's just asking you, is it continuous, yes or no, and then you state the domain. Alright, so are we good there? Now let's go back in and talk some more about these basic graphs, on how you're going to, by knowing these basic graphs. Now if you don't have them all memorized yet, open your book up to that back cover where they're all listed. Okay? Because you're going to have to know what these pictures look like. And then we're going to make the graphing real easy. What was those last two that I gave you in your notes? The
rational function.
which?
The rational and the cube.
All right, but then after we were talking about other graphs back in 2.1, what was it? Wasn't it a square root? No. In the absolute. Okay, so let's look at some other graphs. And like I say, this takes you back to that very end of 2.1. Well, I'm going to talk about an inside of a function and an outside of a function. Okay? And to let you know what I mean, if I say, if a number is being added or subtracted on the inside, then the graph moves along the x-axis, which would mean left or right. Okay? Now let me tell you what I mean by this on the inside. These ones we did at the end of class were on the inside. So So this means that whatever your basic function is, those seven graphs, if it's happening on the inside of it, like if it's happening under the square root, or inside the absolute values. So if I have something that looks like y equal the square root of x plus 2, that's what I mean by inside. That 2 is being added under that square root. Or if I had something like y equals x plus 2 squared, that 2 is being added to the x, then it gets squared, right? Or if I had something like y equal the absolute value of x minus 1, that minus 1 is being subtracted inside of those absolute value bars. You with me? This is actually called a horizontal translation. But it makes it graphing gets a whole lot easier with these. Same thing with your cubes. If I had y equal x plus 1 cubed, that 1 is being added to the x, then it gets cubed. And on all of these, you have to think of your basic graphs. Okay? So on your basic graph, what does a square root graph look like? Right. It looks like whoosh, right? So your basic square root graph looks like that. And where does this point take place at on that basic graph? What's that endpoint?
0.
At the origin. On all of these, do you agree? On a basic square root graph, this endpoint's at the origin. On a quadratic, it's the u, but the base of the u is at the origin. We'll learn later that's called the vertex. On the absolute value, it's a v. That bottom point on the v takes place at the origin. On this cube, remember a cubed, the basic one is this little squiggly. Right here where it kind of does the squiggle, that squiggle happens at the origin. So on all of these, when you're thinking about which way it's going to move, you ask yourself, what number would make it 0? So you're going to ask yourself, because all of the basic ones happen at 0. So when you start to move them, it's going to be, what number would make the inside 0? We know that the quadratic is normally a U shape. We know the absolute value bars is a V shape. And of course the cube basic one is that squiggly. You with me there? So let's look at these. I'm going to draw them real quick right underneath so you know exactly what you're doing here. Alright, what number if you add it to 2 would make it 0?
2.
Negative 2. So that means this graph, instead of it being this basic one right here, it starts at the origin, that endpoint's just going to move back here to negative 2. And you draw your graph. Now, if you wanted to get real ticky with it, you could do a T-chart. I think we looked at that at the end last time, right? Which you could put in your numbers for X. But the only thing about this is when you start putting in numbers for X, you still got to ask yourself, well, I know it's got to start at what makes it 0. So if you did a T-chart, you'd start at negative 2, and then you'd have to think, okay, what other number do I need to put in for X to become a perfect square? So that's a lot more work than just scooting it over. You with me? This one. Okay, we know this is a quadratic, so it's going to be a U shape, right? Because x squared means quadratic, U shape. What number would make this x plus 2 0?
Negative 2.
Negative 2 again, right? So that means the bottom of your U is going to be right there at negative 2. So there you go. We're just moving that basic shape around. You with me? Doesn't this seem easy? This is meant to be easy. All right, look at the V-shaped graph. What number minus 1 gives you 0?
1.
Positive 1. So that means that the base of this V right here is going to be at 1. Bottom point. And then you draw your V. Now to me, this is the easiest thing we've done yet. But the only key is going to be that you have to know what your basic graphs look like, right? And like I say, on your test, you're going to have all 7 basic graphs on there, and you're going to match them all up with the equations. All right, what would make this one 0?
Negative 1.
Negative 1. So that means instead of this squiggly here being at 0, it's going to be here at negative 1. And then you just draw your basic shape. You follow me there? I want you to look at all of these. When you think about what makes something 0, it's the opposite, right? Like here, negative 2. negative 1. So it's kind of the opposite of what you would think is the way you're shifting. A positive 2, well, normally you think, oh, if I add 2 to it, it's going to go to the right. But you're actually doing the opposite. You're doing it on what makes it 0. So if it's a plus, it goes to the left. And if it's a minus sign, it's going to the right. But don't even go that deep. Just ask yourself, what would make that 0? And that's where you're going to put your inputs. Or that's where you put the bottom of your U, or the bottom of your V, or your little squiggly. Every graph has something that takes, all your basic graphs have something that takes place at the origin. And we're not going to do anything with that rational function on moving these around. You okay here? All right, now let's talk about what would happen if the numbers being added and subtracted on the outside. Give a number. So that means we're taking the square root of it, or we're squaring it, or we're cubing it, whatever, and then we're adding a number to it after it's already, the basic part's already been done. So this would be like if I had something like y equal the square root of x plus 2, or y equals x squared minus 3, or if I had something like y equal x cubed plus 1. Or y equal the absolute value of x plus 4. Okay? Do you see where you have your basic function and then this other number is being added or subtracted? Okay, so the number is being added or subtracted on the outside of the function. This is when it's going to be moved up or down. The graph moves up if you're adding, and it'll move down if whatever number is being subtracted. Kind of exactly what you would think it would do. Caught up with me over there? Alright, so it's the square root graph, which we just talked about. The square root graph looks like this, but this time, instead of that being at the origin, it's going to move up 2, because that 2 is being added on the outside. Do you see that? So instead of that graph starting at the origin, it's going to go up and start there. Same thing over here. You see an x squared, so you're knowing you're going to have a U shape. But instead of this U shape, the base of it here being, the vertex being at the origin at 0, 0, it's going to come down to negative 3. Then you'll have your U shape. You follow what we're doing? The cube. I say that cube's your little squiggly graph. So instead of that squiggly right there where it turns, being at 0, it's going to move up here and be at the 1. Then you'll draw your squiggly. Now absolute value, we know this is normally a V shape. But instead of the base of this V, the bottom of the V being at 0, 0, it's going to get moved up and be here at 4. You good there? And this is basically what's going to happen. If you have it on your test, something like to graph, like at the end of 2.1, those problems that you had, that's what you're going to do. And that's exactly what you'll do on the rest of those homework problems there. bonus on your test, it would be a bonus. Well, we'll see if you can put 2 and 2 together. What if I had y equals the absolute value of x plus 3 minus 2?
Can't move a little down.
You know what?
Down.
Right, because you're going to have to move down and over, right? You're going to have to do, because you got something happening on the inside and something happening on the outside. You agree?
Yeah.
Well, start on the inside first. What would make that 0?
Negative.
-3. So you're thinking if it was just this part, that v would be right here at -3. But it also says that I've got to do what since it's a -2?
Go down.
Got to take it down 2. So that means that this bottom point on my v is going to be at -3, -2. And like I said, if I had one that has to do something twice on your test, it will be a bonus problem. Are you good there? Alright, so that's all of the 2-1 and 2-6. So if you had trouble doing these last few on 2-6, 2-1, go back, we're going to go back and do those. You can go back and look at those again. Make sure you know how to do exactly what we just did here. Alright? Now we're going to go, like I said, we're going to come back to 2-2 at the very end. That's the circles. But we're going to go to section 2.3. And like I said, if you took intermediate algebra, 2.3 is going to be a review for you. We're going to talk about functions. Before we can dig deep into functions, we've got to talk about what your book calls is a relation. And a relation is any set of ordered pairs. So it's any set of points. These points might make a shape. You might can play your connect the dots and have some kind of shape, but they might just be scattered out there. But a relation is any set of ordered pairs. Now a function is a special relation. A function is a relation in which none of the x's are repeated. So it means each x can only be used one time. Now we'll read off your formal definition of a function, and we're going to kind of see how these go together. Your book's formal definition says a function is a relation in which, for each distinct value of the first component of the ordered pair, what's the first component of the ordered pair?
X.
The x. There is exactly one value of the second component. So that means for each x, it can only go to one y. But your y's can be repeated. You could have different x's going to the same y value, and that's fine. But your x's cannot be repeated. Okay? So let's look at this. Pretty much what we're going to do in this section is going to be a yes or no, and we're going to state the domain on most of them. So number 1, let's say if I have the relation 2, 3, 4, 9, -1, 3, and 5, -2. We're going to do the function, we're going to talk about the domain, and we're going to talk about the range. Well, would you say this is a function?
Yes.
Yes, because all of my x's are different, right? There's not any x up there being repeated. So my answer is yes, it is a function. Well, my domain, which values are the domain?
X.
The x value. So my domain here is 2, 4, -1, and 5. Range is the y values. So it would be 3, 9, and -2. Everybody good there? Right. I'll leave you a little space over here to the side, because we're going to come back and I'm going to draw something in a minute. the relation 4, 1, 5, 2, negative 6, 3, and 4, 7. Okay, is this one a function?
No.
No. Why? What's being repeated?
4.
Right, your 4 gets repeated. It's not a function. But your domain is 4, 5, negative 6. The range would be 1, 2, 3, and 7. Now your book also does this mapping technique, which you're not going to have on your test, but just so when you see, it might help you understand their definition. They draw these bubbles. They put the domain in one bubble and the range in the other bubble. So you would have here 2, 4, negative 1, and 5, and you've got 3, 9, and your negative 2. Okay, so what your definition says that for each of your first components, it can only correspond to exactly one of the second components. So here this is saying that 2 only goes to 3, 4 only goes to 9, negative 1 only goes to 3, 5 only goes to negative 2. So do you see for each element in this first component, only one arrow is coming from each one. So that means each of the first element is only corresponding to exactly one of the second components. None of the first component is being repeated. Now if you look at this one over here, and you drew that same little deal here, 4, 5, negative 6, 1, 2, 3, and 7. Well here, 4 corresponds to 1, 5 corresponds to 2, negative 6 corresponds to 3, but then 4 is also going to 7. So do you see here you've got one of the first components that's going to 2 different second components. So that's why this one's not a function. Now for me personally, I don't like having to draw this and say, okay, how many arrows comes out of each one? I think it's easier to say, well, are any of these x's being repeated? They're not, so you know your answer is yes or no. Are we good there? That's when you're looking at a relation. Now we're going to talk about when you look at a graph, how you can tell if a graph is a function. Okay. A graph is a function if it passes the vertical line test. And what the vertical line test means is that if you draw a vertical line anywhere through your graph, it can only pass through one point if it is a function. If it passes through more than one point, it's not a function. So a vertical line anywhere through the graph can only go through one point if you have a function. So let's look at a couple of these graphs and see what we can do here. Now all of those basic graphs that you had, you notice that were on the back cover of your book, had this f of x written in front of them all of those are functions. If you look at this back cover of your book at those 7 basic graphs, every one of those pass the vertical line test. If you draw a vertical line anywhere through those, it would pass the test, correct? But only go through one point. Okay, so let's look at some graphs here. We're going to do the same thing we did before. You'll answer yes or no if it's a function, and you'll state the domain. All right, well, let's look at these four graphs. Ready? All right, number one. Would number one be a function? Would this pass the vertical line test? Yes, no matter where you draw a vertical line, it's only going to go through it one time. Yeah, let's talk about why is it the vertical line? What kind of line is a vertical line? Does anybody remember from a previous class? A vertical line is x equal a number, right? X equal 2 is a vertical line where all your x's are 2, correct? We're going to talk about that over when we see one that's not. Because if you have a vertical line, it means you can cross it two places. That means your x's are being repeated at that number. Okay? Because on a vertical line, all your x's are the same. Domain. What's my domain here? What's a function? It goes all the way to the left, and it goes all the way to the right. Domain is negative infinity, positive infinity, all real numbers. My range. What your graph's doing on the y-axis, bottom to top. What's my y value here? 0. Then it goes all the way up. So we put a bracket on the 0 because it's included, and it goes to infinity. We're good there. Number 2. Would number 2 be a function?
No.
No. So when I draw a vertical line, it goes through 2 points. So like I said, say if this was the point 2, you've got 2 going here to 1, and then 2 going to whatever that point would be there. So the 2's being repeated. Okay? Domain. What's my leftmost x value here?
-2.
-2. So my domain goes from -2, and it's going all the way to the right, which is to infinity. Now my graphs aren't great, but this little arrow means that as this graph here is going to continually make that U, and it keeps stretching out. Okay? So that means this arrow is going to eventually go all the way to the bottom. This arrow eventually rises all the way to the top. So my range is all real numbers. Okay? Now number 3. Is number 3 a function?
I don't understand.
bottom to top. So like I said, my little arrows aren't drawn real good, but this graph here, as it keeps going, it's going to keep getting wider and wider, and those arrows are going to keep, this arrow is going to keep, as it gets bigger, keep going up as high as it can possibly go. And if this arrow, as your x's are increasing here, this y values are going to keep going down. It kind of looks like my graph may level off, but they don't. Okay? Next is number 3. Is it a function? No, it fails the vertical line test. Domain. What's my leftmost x value? What's my rightmost x value?
2.
What's my bottom y value? And what's my tallest?
2.
2. Everybody good? Okay, let's look at this one. It's a square root function. Would that be pass the vertical line test?
Yes.
Yes. So it is a function. Domain. What's my leftmost x value?
-3.
So it's going to go from -3 and it goes all the way to the right, which is to infinity. Range. Bottom to top. What's my bottom y value?
-2.
So it's going to go bracket -2 to infinity. Are we good on the graphs? Okay. Now we're going to talk about when we look at an equation. If you just see an equation, how do you know if it is a function or not? Well, most equations are functions. So I'm going to make it easier and tell you what's not a function, because there's not near as many that's not as there are. Alright, so we're talking about an equation. Okay, so it is, first of all, if you have a function, we talked about this last time, if the equation is a function, you can replace the y with f of x, which we taught last time. This is that function notation. Right? So if it is a function, you can use f of x instead of y. That means you're telling me or whatever you see in the book, they're telling you none of these x's are being repeated. It passes the vertical line test. Now we're going to talk about what equations are not a function. So an equation is not a function if you have y to an even power. So if you had something like y squared or y to the 4th, anything like that, anytime your y is to an even power, it's not a function. Or if you have y inside of absolute value bars, it's not a function. Or if you have inequalities. These are the ones that are not a function.
What are the last one?
Your inequality. I mean, you can't have so if you have any less than, greater than, less than or equal to, or greater than or equal to, it's not going to be a function. Like this one here, that's not a function. You would have a y squared if anytime your graph is going sideways and it's a u, that means you got a y squared. Circles, you know, a circle has an x squared and a y squared. And the absolute value of a v would kind of be a v that was going out sideways. Alright, so let's look. We're going to have to talk about the domain of an equation. I'm never going to ask you for the range of an equation. The only thing I'm going to ask you for a range on is if you have a relation or if you had a picture of a graph, because it's easy to see things. But when you're dealing with functions, the domain is the most important part. Because whatever your function is, the x is what you put into it. So you can only put in numbers into it that's going to give you an answer. Of course, you know the answers are the range. So we're going to talk about the domain of a function. on the domain is all real numbers except 3 cases. Number 1, which is if you have a circle, and you just saw on that circle, a circle's got endpoints, right? If you make a circle, it's enclosed, so your range can't be all real numbers. But also a circle, remember, it's not a function, so we're not going to really even deal with the domain on a function, on a circle, unless you're looking at it. On the problems we're going to do, you're only going to tell me the domain if it is a function. So keep in mind, circle, not a function. Okay, but the circle does not have a domain of all real numbers. Number 2 is if you have a square root graph. You have a square root. So remember, we can't take the square root of negative numbers. So if you have, let's say, y equal to the square root, and I'm just going to put a big star over here, because it might be x plus 3, it might be x minus 2, it could be 5x plus 1. So we're just going to say that if you have a square root, you got something underneath that square root. We can only take the square root of positive numbers. So to find the domain here, you have to set what's underneath the square root greater than or equal to 0. So to find the domain, you set whatever's underneath that square root greater than or equal to 0. So let me give you a quick little example so you understand exactly what I mean. So if you're given, say, y equal the square root of x plus 4. First of all, you'd ask yourself, is it a function? Is this y to an even power?
No.
Is this y in absolute value bars?
No.
No. And then you don't have an inequality. So yes, and you already know the square root is a basic function. You already know those are all functions. But now you got to find the domain. To find the domain of y equal the square root of x plus 4, you got to say, well, this one, x plus 4 is greater than or equal to 0. Because you can only take the square root of positive numbers. Solve for x. So I need to subtract 4 from both sides. So your domain is when x is greater than or equal to negative 4, which you would write that in interval notation just like you did in your last test. So your domain would be from negative 4 to infinity. You put a bracket on the negative 4 because you can take the square root of 0. That would give you that endpoint, remember? And this is going to be another thing. If you're struggling, remembering, trying to do this, think about what we just did with those translations. Square root of x plus 4. What would make that 0?
Negative.
Negative 4. So that's where that graph would have to start, right? And then it would go all the way over. You with me? Alright, so that's the second case, if you have a square root function. Okay. The next case is if you have a rational function. You have a rational function, the domain's not going to be all real numbers. Because what's a rational? A fraction. And what can you never divide by? 0. So if you have a rational function, you must throw out the number that would cause you to divide by 0. So whatever number causes you to divide by 0, you got to throw it out. It cannot be part of your domain, because if you use that number, you would get an error on that calculator. No solution. Let me show you what one of these would look like. So if I had y is equal to, let's say, 3 over x minus 6. Alright, well let's look at this. What number would make that 0?
6.
Positive 6. So for my domain, x cannot be equal to positive 6. So what can it be? It can be everything else, right? So if you're going to write this in interval notation, that's from negative infinity to 6 with a parentheses, union 6 to infinity. That's one of those where you'd have, on this one, it'd actually be a vertical asymptote. It's kind of like we had earlier when you had that hole in your graph. Remember, it was everything up to that hole, and it would be everything on the other side. So it's everything up to 6, and everything on the other side of 6. You with me there? So the only two cases you're going to have to worry about are 2 and 3. Square roots and these rationals. Everything else is all real numbers. Okay? Good? So we're going to do just like we did a while ago. I'm going to give you several equations, and you're going to tell me if it's a function, yes or no. If it is a function, you'll state the domain. So our directions are the following functions. If yes, state the domain. That's how it's worded on your test. Let's look at these 10. Okay, so first of all, let's go through and say if each one's a function, then we'll go back and do the domain. So if it's a function, that means y is not to an even power, y is not inside of absolute value bars, and no inequality. So is number one, would number one be a function?
Yes.
Yes. Plain y. What kind of graph would that be? X and y are both to the first power. What kind of graph is it?
Just a basic.
Just a line, right? If x and y are both to the first power, you have a line. Okay? Number two, would number two be a function?
Yes.
Yes, plain y. Anytime you just have a plain y as a function. Y is not to an even power. Y is not in absolute value bars. No inequality. So yes, this is a function. What kind of graph would that be? Your highest exponent is a 2. Be a U-shape, the parabola, right? Basic graph. Alright, it's got a lot more other stuff going on that we'll worry about way later on graphing that, but it would be a U. What about this one? Is this one a function?
No.
Look at y.
Yes.
Oh, yeah.
Plain y. Yes, it's a function. Look at number 4. Plain y.
Yes.
Yes. Look at number 5. Plain y. Yes. Plain y.
Just looking at the
We're just looking at the y's. Number 6.
because it's not with the
We
inequality.
got an inequality. Okay. Number 7. No, because y is inside of absolute value bars. What about number 8? No, because y is raised to the second power, which is even. What about number 9?
Yes.
Yes, y is raised to an odd power. That's okay. What about number 10?
Yes.
Yes. All right, now we're going to add. So first of all, we thought we looked at the y's, even powers, absolute value, inequalities were not functions. If it happened to the y's, everything else was. Now let's go back and do the domain. Alright. Domain is all real numbers except on square roots and on these when x is in the denominator. So what's the domain here?
Negative infinity to infinity.
All real numbers. You don't have a square root sign and you don't have an x in the bottom. You don't have a fraction. This one here.
All real numbers.
All real numbers again. No square root, no x in the denominator. Number 3. All real numbers. No square root sign, no x in the denominator. Number 4. Well, we got a square root sign. So let's figure out the domain. We just said whatever's underneath the square root, you set it greater than or equal to 0. That means it's got to be positive. Positive numbers are greater than or equal to 0. So now we want to get x on the side by itself. This is when 2x is greater than or equal to -1. Divide both sides by 2. So it's when x is greater than or equal to -1/2. So my domain in interval notation would be a bracket, -1/2 to infinity. And once again, it's what would make that 0, because that's what we scoot that endpoint to. So whatever's underneath, you set it greater than or equal to 0, then you solve for x. You get x on the side by itself, just like you did on your last test. Number 5. Well, I don't have a square root, but I got an x in the denominator. So to find the domain here, we know that this denominator cannot be equal to 0. So let's figure out what makes it 0. Well, that would be when 2x is equal to +3, divide both sides by 2, so it's when x is 3/2. It's what would make that denominator 0. So that's what x cannot be equal to. So my domain is from -infinity to 3/2, parentheses, union, 3/2 to infinity. You just split up the all real numbers at the number that made it 0, because you're throwing it out.
So that's just the denominator? But
Yes, it's only the denominator. You're not worried, because it's only what would cause you to divide by 0.
Okay.
Alright? Let's look at the next one. But this is a no, that's a no. We only worry about when our answer is yes. So let's go to number 9. Okay, do you see a square root sign on number 9? No. Do you see an x in the denominator on number 9? No. So your domain here is all real numbers. You can put in any number for x and you can solve and find a y. Number 10. Number 10. Do you see a square root sign?
No.
Do you see an x in the denominator? So your domain here is all real numbers. So to recap, you ask yourself, if it's a function, do you have y to even power, y and absolute values, or inequality? Those are not functions. Then to do domain, it's all real numbers except on these square root graphs and when x in the denominator. You good there? Now we're going to talk about evaluating functions.
Can you explain that down real quick on the domain? I was trying to catch up.
Okay, your domain is all real numbers except when you have a square root sign or if you have the x in the denominator. So neither one of these, you don't have a square root sign and you don't have a fraction.
Okay.
So the domain's all real numbers. Alright, so next, function notation. Alright, like I said, let's look at this real quick. Alright, function notation. Just said is f of x, and it replaces the y. It's read f of x, and it replaces the y when you have a function. Okay? Well, first of all, let's just say if I had y equal x plus 1. What kind of graph is that?
A line.
homework for today, or you could do a T-chart. All right, on a T-chart, since there's not a fraction, we probably want to do -1, 0, and 1. Remember doing these? You did a lot of these for intermediate. So this says when x is -1, what's y? So y would be equal to -1 plus 1, which is 0. You put a 0 in place of the x. When x is 0, y would be 0 plus 1, which is 1. When x is 1, y would be 1 plus 1, which is 2. So that would be the points on that line. And you can plot those 3 points and connect them, right? If I want to graph it, so we've got the point here at -1, 0, 0, 1, and then at 1, 2. So that's the graph of that line. And remember, you could have also graphed that line x and y intercepts, which we went over last time. X-intercept is when you let y equal 0. Y-intercept is when you let x equal 0. But actually, right here, I have them. Right? Isn't this the x-intercept? Isn't this the y-intercept? Okay. Well, you've done a T-chart. And the best thing about this T-chart is no matter what kind of graphs you're doing, you can always plug in some numbers for x and figure out what is y when x is that number. And you can graph any function you wanted to. Even all those that I told you that we did earlier. Instead of just scooting them around, if you don't like that scooting, you can do your T-chart and you'll get the same graph. It's just going to be a little bit more work. It's easier if you scoot them. Alright, but what we're going to talk about function notation, do you agree that this line would pass the vertical line test? Yes. This line is a function. Well, when you're given function notation, you're going to be asked, say, if you're given f of x is equal to x plus 1, because we can replace that y with an f of x because it is a function. It does pass the vertical line test. So let's say if you're given f of x is equal to x plus 1, in function notation you'll be asked to find, say, f of -1. But that's the same thing. It's the same thing you just did right here. There's no difference in function notation and doing a T-chart. They're exactly the same thing. It's just written a different way. Okay? So if you're given f of x is x plus 1, and you're told to find f of -1, whatever's in this parentheses, you put in place of that x. Whatever's in the parentheses goes in place of the x. Look right here. -1 is replacing the x, so let it replace the x over here. That would be -1 plus 1, which is 0. That means f of -1 equals 0. It also means that the point -1, 0 is a point on this graph. If you're looking at a graph, whatever's in the parentheses, the answer is the y part. F of x, f of -1 equals 0, the y part of the T-chart. You see what I'm doing? Number 2, if I was asked to find f of 3, how would you find f of 3?
Put 3 where x is.
Right where there's an x, you put a 3 in its spot. So that'll be 3 plus 1, which is 4. So f of 3 is 4. And do you agree that that's a point on, oops, hold on, I just wrote that back. F of 3 equals 4. So that means that the point 3, 4 is a point on this graph. And would it not be? There's 1, 2, 3, 1, 2, 3, 4. You got that point on there, right? So that's what it means. Whatever's in the parentheses is the x. The answer, when you substitute that number in for the x, gives you the y. It gives you what it equals, just like this T-chart did. Are you good there? Next, let's change our function. A lot of times you'll be given 2 different functions. Let's say if you're given f of x is equal to x squared minus 3x plus 1, and let's say that g of x is equal to negative 2x plus 1. Okay? And this time we want to find, let's say we want to find f of 3, and we want to find g of negative 1. that number is in front, that tells you which function you go to. So since it's an f of 3, I go to my f of x function. Everywhere there's an x, I need to put a 3 in its spot. So f of 3 would be 3 squared minus 3 times 3 plus 1. Well, what do you get when you say 3 squared? 9. Negative 3 times 3 would be negative 9 plus 1. Well, 9 minus 9 is 0, so I'm left with a 1. So that means f of 3 equals 1. Alright, we go there. Find g of negative 1. That means go to your g of x function. Where there's an x, put a negative 1. So that's going to be negative 2 times negative 1 plus 1. Well, negative 2 times negative 1 would be positive 2 plus 1 gives you 3. So that means that g of negative 1 equals 3.
So even though it's, like, that's F, G, that could be any letter.
Yeah, and normally, yeah, it can be anything. Usually it's F, G, or H.
The X
Right.
is what we're gonna be replacing every time.
Right. And either way, whatever the answer is would always be the y coordinate on your graph. Okay? Alright, let me give you another one. I'll give you some more here to do. Let's say this time, if I told you that f of x is negative x squared plus 3, and g of x is 4x minus 1. Let's say if I want to find f of negative 2, I want to find g of 5, and then I'm going to find f of negative x. Find 3 and 4 first, and then we'll talk about that negative x being in the parentheses. So that would be a negative 2 squared plus 3. Now, remember your exponents only go with what they're attached to. This negative is tacked out front, just like if you'd have had a 4x, you'd say 4 times x. And you got to square this negative 2, then multiply it times the negative. So negative 2 squared would be what? 4 times the negative would make it negative 4. So you get negative 1. So f of negative 2 equals negative 1. One thing, look at this right here. So you'll know with your answer. This kind of goes back to what we did last time with the sign charts. How many negatives do you see in this problem? You got 2 right here, and then 1 out front. So you got 3 negatives. What do odd number of negative signs make?
Negative.
Negative. Okay, so my answer there is negative 1. If I want to find g of 5, that would be 4 times 5 minus 1, or 20 minus 1 is 19. So g of 5 equals 19. That means the point 5, 19 is a point on that line. Now this negative x, it's f of negative x, so that means wherever there's an x in your f of x function, put a negative x in its place. So that means here this would be a negative x squared plus 3. Once again, how many negatives do I have right there?
3.
3, so what's my answer going to be?
X.
It'll be negative x plus 3. When you square a negative, you get a positive times the negative out front, makes it a negative x plus 3. Get it there. All right, let me ask you this, talking about functions. Now we said whatever's in the parentheses is the x. Your answer is always the y. Okay? Like I just said here, that means on this particular line, the point 519 is a point on that line. Okay? Okay, let's say if I gave you the relation 2, 1, 6, 4, and 5, 2. Okay, first of all, is this a function?
Yes.
Yes, it is a function. So what if I ask you to find f of 6? What's f of 6 equal to? 4. Whatever's in the parentheses is the x. Remember, your answer is the y. What we just did here. So if I ask you to find f of 6, you're like, okay, well here when x is 6, the y value is 4. And if I ask you to find f of 2, what's f of 2? 1. Okay, so you can do functions looking at a picture, looking at the relation. Also, let's look over here at the smart board and let's see, looking at a graph. Get this to look at the graph without messing everything up. It might not show it anyway. Okay, looking at this graph that I have over here. Alright, if I want to find f of 0, what does that mean? What the parentheses is always what value?
X.
The x. So it means when x is 0, what is the y? Right there, right? So f of 0 would be negative 5. And then if I wanted to know f of 5, well that means when x is 5, which is here, what is the y value?
0.
0. So you follow how you do it looking at the graph. Okay. Whatever's in the parentheses is the x. Okay, remember this is f of x, and remember f of x equals y. Remember? We said f of x can replace the y. So whatever's in the parentheses is the x. So f of 5, when x is 5, what is y?
Okay.
So this is when this is the point 5, 0. So when x is 5, the y is 0, just like it was on the relation. Okay, we good there. All right, one more thing in this section. Let's get back around to you. All right. Last thing is sometimes the way the function is written, you can't tell if it's a function or not. You might not be able to graph it or get your function notation is easy. So if you're given a problem, and I'm going to do number 64 in your book. On 64, you're given x minus 4y equals 8. Okay? Well, you're asked to put it in function notation, write in f of x form, look kind of silly to say x minus 4 f of x equals 8. Most of the time the f of x is on the side by itself. So if something's written like this and you're told to write it using function notation, that means you need to get y on the side by itself. First of all, this is a function, plain y. So let's get y on the side by itself. We need to move the x over, right? So that'll give me negative 4y equals negative x plus 8. Now what do I need to do to get the y by itself? Divide everything by negative 4. So that gives me y is equal to 2 negatives make a positive 1/4 x minus 2. Now I can write it in function form. I can replace the y with f of x. So f of x would be equal to 1/4 x minus 2. Now you can find f of 3. So that would be 1/4 times 3 minus 2. Or 3/4 minus 2. You can either do it on the calculator. Everybody showed you how to hit those buttons early on in the semester. Or you can go ahead and get your common denominator, which would be 4. This 2 is understood to have a 1. 1 times 4 is 4. 4 times 2 is 8. So that would give you negative 5/4 would be your f of 3 there. And yours aren't that bad. You need to add 63 somewhere. Okay, so that's what you would do if you had something like that. So on your homework, you're going to go back and you're going to do some more of those graphs in 2-1, and then you're in here in 2-3, doing all this function notation. Now it looks like a lot, but all of this in these first sections are answering yes or no, and stating domain and range, which that doesn't take long. All right? Y'all have a good weekend. If anybody was not here last time, come and see me. And also, if you came in late, come and see me.